In this video, we're going to talk about mass and weight. What is the difference between them? When to use the word mass and when to use the word weight in a conversation. We have been using it wrong. How is that we have been using it wrong and what is the right thing to use? We'll be understanding in this topic. To begin with, I have a small question for you guys before I explain. Whatever is your opinion, you guys can have it. Then I'll explain from my end. So the question is this. This person is holding this vegetable and he or she is thinking about what is the weight of this particular vegetable. Is it half a kg or no? So my question to you guys is, do you find any error in this writing? Is there any error? Is there any error? Yes or no? Actually, there is an error. Actually, there are two errors. Can you figure out what are those? One is it doesn't have a question mark. And the second thing is this is supposed to be mass. Okay. So the actual question should have been, is the mass of the object half a kg? Should have been his thinking. Okay. This is the actual right statement. And this was wrong, kind of. Okay, so the mass is something that you measure in kg, not the weight. There's no 1 kg weighing object. Understood? So we'll understand in detail over here. Okay, if you're not understood over there, we'll understand over here. See, when we're talking about mass, we have to talk about what is it made up of. That's the whole idea. Say I have a box which is made up of say 10 atoms. Again, technically, it won't be so. It will be crores and lakhs and so on and so forth. But it won't be 100 atoms. But we'll consider 100 atoms. Okay. So this box is made up of 100 atoms. So the mass of the object is what it is made up of. Again, I repeat, the mass of the object is nothing but what an object is made up of. So my question to you guys is, will this object have the same number of atoms if we take it to different places on the surface of the earth, on the surface of the moon, on the surface of the sun? Will it change or will it be same? It will be same, is it not? And thus the mass of the object will not change. It remains constant even though we change the location. The mass of the object, it cannot be zero. Okay, the mass of the object cannot be zero. The unit of mass is always in kg. Okay guys, so let me explain again. Any object is made up of certain number of atoms, right? This number of atoms will not change wherever you go. So the mass will remain constant. Okay, it cannot be zero. Obviously, if there is a material, it has to be made up of few number of atoms at least, is it not? So it cannot be zero. And the measuring unit is kg. Okay. So a mass is measured in kgs. Now against this, the weight is measured in Newton. But Newton is supposed to be force, is it not? The word Newton, the unit as in unit, it's supposed to be a force. So is weight a force? Yes. Weight is a form of a force. Weight is the name of the force exerted by an object due to acceleration due to gravity. In a simple word, it is nothing but the gravitational. Whenever there is a gravitational pull, the object will have weight. So your weight is because of gravitational pull. If there is no weight, if there is no gravitational pull, you will be weightless, not massless, weightless. Are you getting the technical difference? Right? Have you heard the word weightless, weightlessness? Have you heard of this? So please web search this weightlessness feeling or video. You'll get a lot of astronaut videos. They'll be floating around. They're experiencing weightlessness. So you need to know the difference. So basically it can be zero. Is it not? Technically, if there is no gravity, what will happen? If there is no gravitational pull, means the object will not experience any weight, but mass will not become zero that moment of time. So it depends on the location. If a person is standing on the sun, his weight will be a lot more than in comparison to that of the earth. It will be a lot less when you it will be a lot more when you are comparing it to standing on the surface of the moon. What I mean, I'll explain in time. I'll be explaining with the help of Python coding, the graph and all of that. So you guys got the basic difference. As a definition, mass definition is this. We are using Newton's first law to explain mass, the idea of mass. Okay guys. So again, let me repeat, mass is what an object is made up of. And so it cannot be zero. It cannot have, an object cannot have a mass of zero. It is independent of location. Wherever you take, the mass of the object will be the mass of the object. And the unit of measuring it is in kg. Okay guys. While weight it depends on the location, because it is a form of a force. And this force needs another object for it to have a weight. So yes, it's possible for us to feel weightlessness, that is to have a weight of 0. And the unit obviously should be Newton, because it's a form of a force. Agree? So what is the point of learning this, differentiating this, and where are we applying it? So to talk about that, we'll begin with discussing about mass versus weight on celestial bodies. Then we'll talk about on the surface of the earth, okay, how the idea of mass can be used to make profit. Technically, it is possible. Obviously, it is not done on the surface of the earth. Using the concept of weight, how can we make money? And we'll be talking about a very interesting topic, that is moonwalk. Right, but we'll begin with celestial plot of mass versus weight on the celestial body. We'll try to concrete this idea of mass and weight, and we'll answer this question. Okay, it's a very interesting thing. I hope you guys like this. And one more thing which we can talk about is red planet, Mars. So we'll be talking about that also. Then we'll be talking about Mars mission and moon mission also. So we'll be talking about all of this just to cover the idea of mass and weight. Okay, so let's begin understanding a lot more. Now, first this is a program to calculate the mass and weight of a person on a celestial body. Okay guys, so here I ran the program. The program is asking, enter your mass on the surface of the earth in terms of kg. So say I am around 68, so 68 kg person. How does it weight and mass vary? So there is calculated value over here. And this is a graph of mass and weight and mass on the surface of the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Moon. Okay guys, so we'll be looking at this. Weight is measured in Newton and mass is in kg. And mass is, okay, let me not show you guys that. My question to you guys is, looking at this graph, can you tell if the triangle shape is there, right? Can you see this? Is it representing mass or weight? My first question to you guys is that. Please close your eye. You had a look at the graph now. Can you see that? Just have a look at that. Don't read anything else from the graph. Do you think this triangle represents mass or weight? Yes, majority of you, I can see that you guys are telling mass. That's correct. Mass is constant. So you keep it on any point on any surface. Doesn't matter. You keep it on Sun, Mercury, Venus, Earth, Mars, so on and so forth. The mass will remain constant. Can you see that? It remains constant. Right guys? While the weight is a lot more, less, blah, 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 blah. So many things are happening over there. Can you see the weight of a person on Earth and weight of a person on Sun? It's so much. And this is on the Earth. Okay guys. Actual value is how much? I am weighing around 660 Newton. I'm experiencing this much of force. Right? This much of force is exerted by me on the earth, and the earth is exerting so much of force back. Right guys? On the surface of the moon, if by chance, if I'm able to go and stand over there, I'll be experiencing 18,000 odd Newton of force. So almost by a factor of 270.7, right? By this factor, you have to multiply 68 with this factor, and that will be the weight. On the surface of the earth, it is 9.8. And on the surface of other places, we'll be analyzing that also. So my next question to you guys is, in comparison to earth is over here. Where and all will we weigh same? My question again, we are on the surface of the earth, you can see the circle. Where will we weigh? Our weight will be almost same. Again, it will not be exact, almost same. Where and all, which and all places on the graph will be experience the same force, same weight. Which all places? Please pause and think over. Yes, Venus, Earth, Saturn, Uranus, and Neptune. They here in all of these planets will weigh the same. If just it had bit of air and water and good enough sunshine, it would have been another Earth. Of course, it's not so. We are in that zone wherein the temperature is good enough to sustain life. Before that it's too hot, after that it's too cold. Not very cold. Obviously, we can go to Mars and colonize that. So yeah, you guys got the idea, right? So in all of these places. So in which place, again on the graph, do we weigh the highest? And on which place, on which planet do we weigh the lowest? On which planet do we weigh the highest and lowest? Is my question. Yes, we weigh the highest on the surface of Jupiter. Okay, guys. It's around 1500. And on the surface of the Mercury, not Moon. If you guys had thought of Moon is not a planet. Mercury is a planet. And on the surface of the Mercury, we weigh the lowest. And even Mars actually. So that's a good thing. Okay. Why is it a good thing that we weigh less over there? Why is it a good thing? We'll understand that in time. In this video itself, don't worry. Okay, guys. You understood the difference? In which planet do we weigh, is our mass same? In which all planets is our mass same? Mass is same everywhere, it doesn't matter. Okay guys, understood? So, what did we learn? That on the surface of the earth, if we weigh so much, our weight on the sun will be so much more. On the surface of the earth, on the Mars, it's almost half the value. You can see the acceleration due to gravity. If Earth approximately is done, Mars is 4, less than half. How does this help? Okay. On the surface of the Moon, it is 1/6 actually. 1/6 that in comparison to that of the Earth. So how will this affect us? Keep this in mind. If Earth acceleration due to gravity is 10, Mars is 4 and Moon is 2. How will this add up to? What is the significance of this is what we're going to understand. And remember, all of this coding is available, right? You guys should be executing, putting your values and executing and all of that. That opportunity is given. Please make use of it. Try to research, try to understand. Change these factors. Try out what will you weigh on the surface of the, say, nearest star, the biggest star that we know, biggest planet we know, highest density, planet with highest density we know. All this new facts you can web search and find out and just run this program. Again, it's a simple calculation thing, but yes, it's fun to do all of this, right? You're learning something new, right? You can learn coding basic. Remember, we have all of that. Everything is ready. It's just that you guys have to make use of it. Okay, guys, do enjoy your learning. Just don't learn for the sake of it. Now, so scatter plot we saw. So how is that we're going to make money with the idea of weight? See, whenever you measure something, yes, end of it we talk about mass. But what we are actually doing is we are using the idea of weight, and from that we are measuring things, finding the mass of things. So technically it's possible to say use something like takdi. Takdi is that weighing, balancing thing which people use it for vegetables and all that. So if we have that, and if we go to this longitude, right? I think it's longitude. Just correct me if I'm wrong. So if we go to some European or Russian or Canadian or US country, or there are many, Norway or Sweden, so on and so forth, If we go to some of these countries and buy gold, I think gold is AU symbol, and come back to equator. Okay guys, technically here it will weigh more. Why? You guys have seen this. We weigh more on the surface of the earth at the equator than in comparison to the pole. So if we get gold from the pole and weigh it, like say there is a gold person, goldsmith and stuff, is selling gold. If you buy say 10 kg, if you come over here using the same how do we put it, weighing machine, digital machine or something like that, if you try to weigh it, it will weigh more, so this person buys it over here. If we come over here, he'll weigh more. Obviously he'll weigh more for the reason you guys know already, because acceleration due to gravity is more over here, right? It's bulged over here, the radius is more, so on and so forth. Here the radius is less, so on and so forth. So technically you will weigh more over here, or the gold will weigh more over here. So the difference in the weight, you can earn money. Of course it's not possible in a sense, as of now, buying so much of gold and taking it across, highly impossible, and the difference might be very minute, and the petrol cost will be so much. Anyways, I might be wrong, you guys can calculate that. Of course, to overcome this, there are many things that people are doing, or governments are doing, organizations doing to correct this error, and it's been corrected. It's not that it's happening, but yeah, you guys got this. So they change the definition of how to weigh something, how to check the mass of something. So all that is a new development that's happened from past a decade. Okay, how we weigh the object, how we check the mass, the technology has changed, right guys? So this is how we can make money, just by buying a gold at near the pole and getting it to equator and selling it. Now next thing, moonwalk and moon mission. Please go web search about moonwalk and moon mission. So during the Cold War, US sent few set of people on the surface of the moon, and the way they walked was funny. I have seen that. I have seen this, with the suit and all of that. Right guys, with the suit and stuff, the way they walked, it was kind of funny. They kind of woggled around and they were floating, to be frank. They looked like they were floating, as if they were in water, right? In water you kind of float, not kind of float, we can float. And when you fall also, if you just want to fall off also, you'll fall slowly. So that's what happened with them also. They fell, but not at the same rate as on the surface of the earth, right? So why is that happening? Because they weigh less. How much less? 1/6 their weight. So technically, if a person stands over here, right, say I'm drawing a very small diagram, if they're able to jump to this height on the surface of the earth, it is possible for this person with the same amount of strength to jump to this height on the surface of the moon. Same person, same strength. Because they weigh less, that is, the pull is less. It's a force, remember. The pull is less, so he or she will be able to jump to this height. On the Mars also, he or she will be able to jump to this height. Again, because they weigh less on the surface of the Mars. Right guys? So again, how is this useful? Matlab, all this is okay and true. How is this useful? Well, I'm asking you this question. All these people came back. People who went on the moon mission and all that, they came back. Right guys? So my question to you guys is, how did they come back? Because to send someone out of space, we have seen that big rocket having so much of petrol, or not petrol per se, having so much of fuel, blasts off with so much of gas and everything, is it not? So how did they take such a structure on the surface of the moon? How did they come back? What kind of vehicle did they use? What kind of launching thing did they use? You have to web search all this, research about all this. So technically, when we end up going to Mars, how will we come back? In the sense, if someone wants to come back, right, how will they come back? What should be the fuel used? How much energy should it have? How much push should it have? Right, so all of this you can research. Mars mission, right? You can web search all of this and see how the idea of weight and that it is not constant, how it is used, and how humans are able to send themselves, come back, and so on and so forth. Okay, guys. So you can learn about all of this. It's not a, yes, it's a small concept. I won't tell it's a big concept. Technically, it's only this, but application you can see so much. Is it not? Right? Some idiotic thing like buying a gold from there and coming over here to talk about it, it's fun. I agree. Even I like the idea, but it's idiotic. It's not practical. And this is all practical. Moon mission, moonwalk, Mars mission. How much? There's a Mars movie also, movie based on Mars. Like you send in person over there and he comes back. You should watch that. You'll understand. Okay, guys. So all of that you can understand. And there are quite a few things. Let me not extend this video. There are quite a few things. I'm not talking about. I wanted to talk about more things, but I'm not talking about that. Chalo, anyways, let's pause and think over what to write. So do write the heading, do write this diagram. Again, all this helps. Then yes, you need to write this theory part. Okay, guys. And yes, possibly if you're able to make a small note and diagram like all of this diagrams, it'll be fun. Right. So this is jumping diagram. Again, I'm not able to segregate this. Let me kind of help you guys out with that. So you can have this as a separate diagram. It'll be fun. This again, he was floating. Launch, this is related to this. So this is one. Then gold thing is another one. And this is future. Okay. So all of this you guys can draw a separate diagram. So again, try to learn as an idea and it's fun if you ask me. Okay, guys, please do that. Yeah, please pause and write all of this.